So in this lesson, we're going to just have a quick look at how to do Caesar ciphers and ciphers in general in Python. So I've got some examples here of what a cipher is. You've probably seen it before. Basically, you shift everything down one letter in the alphabet to make it code. So A becomes B, B becomes C, C becomes D. So if I was to say AB, you would say, oh, you mean BC. So it was invented by Julius Caesar, and that's why it's called a Caesar cipher. He used a cipher that was A to D. It was a 4-letter +4 cipher. A becoming D, B will become E, etc. So when he was sending messages to his allies, he would encode them in this way. Everything he wrote, he put in a Caesar cipher if it was important. And then his son, Augustus, actually, he was a bit of a rebel, didn't like to match his dad, so he used a +1 cipher. Kind of a tribute, you know, saying, I respect what you did, but I'm going to make it a little bit easier. Maybe he just, 4 was too much, you know. Both very successful Roman empires, and look them up for some crazy life stories. Yeah, we're going to do one in Python. As part of this lesson, really the focus of, I suppose, of it is not just making ciphers, it's how to manipulate strings as well. So here we have a message. I've called it my message, and it's a string, run, with exclamation mark at the end. So if I want to select the first letter to shift that down, I'm going to use my message, which is the name of this, the string, and I just go square bracket 0, okay, which is the first term. We have got 1, 2, 3, 4 characters in this string, or UN exclamation mark. We don't count 1, 2, 3, 4. It's programming, so we count 0, 1, 2, 3, 4. It's kind of strange. You know, we count to 4 and you end up with 5 fingers up. That's how the program works. So the 0th element is the first one. It's OR. It's for turn OR. And the problem is, it'd be great if we could just add 1 on there, but we can't, because you can't add 1 to toast. You just can't add numbers and words. We have to add numbers to numbers. So luckily, we can do that by realizing that actually computers, as far as they're concerned, they're not using letters. Computers, from their point of view, all letters are already numbers. You know, so if you got like the computer, it says in binary, you know, computers have on and off, 1 and 0 binary. And if computer gives you the binary number for 65, so that's like a whole string of 1s and 0s, right, to get to 65. It will return the character A, capital A. If you want a small a, you got to go with 97 over here in the table. Okay. Even if you want an exclamation mark, that's 33. Right. Now there are other columns here in this. I just didn't really want them in here, but they're here anyway. So hex and oct, all they mean is there's a few different ways of saying the number 1. Okay. Yes, for very low numbers, like 1 in decimal, base 10 is 1 in binary, because it's also 1, and same in hex and oct. So it's just that in binary, because it's base 2, once you get to 2, you got to add on another number to it. And in hex, you don't do that until you get down here near 15 and 16. So an oct, it's near 8. So this has nothing to do really with what we were talking about. You can just ignore the hex and oct here. We're looking at the decimal, okay, which in Python we say is ord, and then over here the characters. These are the actual characters, like plus and blah blah blah. They're the only 2 columns we're looking at. Let's have a look at them. I print my message. That'll print OR. Okay, but if I want to go ORed my message, that's basically take the character here was OR, capital OR, and convert that into the decimal. I don't know what OR stands for. Maybe I'll go say OR decimal, OR D for decimal. That's not what it stands for. I'd be surprised if it was. Ordinal number? I don't know. So yeah, let's look that up. We have capital OR. So where's capital OR in this chart? There it is. or 82 in decimal. All right. So when we do ORed by message of the first character, we will get 82. That's what comes out of the program when we run it. Now we can go backwards, but instead of using ORed, we can go CHOR to go back to characters when we have a decimal. All right. So to go from, let's say, K into 75 here, we would use ORed. And to go from 75 back to K, we'd use CHOR, turn it back to a character. Grand. So we've got kind of all the tools we need. I think our strategy here is going to be turn it into a number, add 1 to it, turn it back into a letter. Makes sense. That we can sidestep around the adding 1 to toast problem. So here we go. We've got a message. We print it again. It's good to have some diagnostics here to make sure the program is running, there's no problems with it. That prints the first one again. Yep, grand, that's OR. Now ORed my message. So let's take the OR here and get the ORed of it. So that's the decimal. And that will print 82. Once we've got that, we can add 1 to it. Yeah. We can add 1 to it. So we've got that. We add on another 1 and it goes up to 83. Deadly. And now we just need to whack it back. So this is as far as we got last time. We were up to 83 here. Okay. And then now that we are at 83, we want to turn that back into a letter. So we put CHOR bracket in front of it. Okay. Now this might look a bit complicated, but let's just talk through it. Because if you started the inside of the bracket to work out, you will be able to follow along, right? This is the string my message, which you know is run exclamation mark. This is the first character of it. Okay, the 0th position, index 0 or capital OR. We got a capital OR. We turn this using ORed into 82. Then we add 1 to it. It now becomes 83. Now we've got 83. We turn it back into a character using CHOR, and we get S. Okay, so OR is turned into S. Deadly. That was that for the first character, 0. But we need to do it for the rest of them. We need to do it for the U, the N, and the exclamation mark. So that's what I've done here. 1 is the U. At position 2, so 0, 1, 2 is the N. And at position 3, so 0, 1, 2, 3 is the exclamation mark. I'm going to add 1 to each one of them. Then when I'm all done, I'm going to add these strings into a nice coded message and print it. When you do that, you get capital S, VO, and then it's actually a quotation mark here, because if you look back up the thing, you got exclamation mark has gone up 1 from 33 down to 34, so it's turned into quotation mark. That's that. Super. Now you'll notice that this only works for the case where it's a 4-letter word. So we need something that will work for everything, I suppose, if you were to really do this properly. So what I've done here is, this could be an input where someone could type it in, but I've done run again just for simplicity. I'm going to use a for loop because I can see, look, this is the same thing again with one thing changing. And that's when you should be thinking, I could do this in a loop. Okay, so this here is going up by 1 or iterating, okay, by 1. And that's your I here. We tend to use I. I'm guessing it's probably stands for it already. I. This is going 0, then 1, then 2, and going up like that as this counts up. Great, and we add a 1 to it. The only thing is, if I want to do this for a 4-character word, I'd put 4 there. A 5-character word, I'd put 5 there. The thing is, I don't know how many characters they're going to type. So what I'll do is I'll say, get the length of the message. So just put len and in brackets the name of your string, and it will return how many letters in that word. So that's going to be my limiting factor here. Not 3, not 4, because I don't know what they're going to type. So I'm just going to say the length of their message. So if they type a 5-letter word, this thing only goes through 5 cycles and stops. Okay, so here's some things you can do as your assignments. you can write a program that converts HAL one letter to the right in the alphabet. And that is actually an Easter egg that was in the movie A Space Odyssey that they put in intentionally. So you can, well, you can probably do it in your head, but do it in Python, you'll find out. You go like, oh, I see. It's very famous. Well, yeah, you'll still recognize it. I think if you know anything about computers or names of computer companies. So that's where they got the HAL name from. If you can make a program that can both encode and decode, that would be great. So that's to do the same thing again, except instead of maybe just subtract. You know, that's a medium task. So there's also lots of different ciphers. I mean, I've given you an example there of a cipher which just adds something to it, but like you could use add, get the square root of it. You could multiply, divide. You could make up your very own cipher that only you know the algorithm to. So only you could encode and decode messages, and you could just save that as a Python thing, and there you go. You'd have literally your own secret code language, which would be pretty cool, and you can get very creative with it. And the last one, this is pretty good actually. So yeah, there's something about interesting enough, back in World War II, the Germans would they kind of use Enigma. Of course, they'd have an Enigma machine. The other person would have an Enigma machine. The Enigma machine, they type in the message, and it would come up and light up with different keys. So K would become a W, W might become a T, and every morning they'd change the wheels on the Enigma machine because they had a little calendar with the settings for Monday. I'd change this to 21, this to 18. And then even if the Allies figured out the 400 quintillion combinations for the thing, which would be basically impossible to do by hand, it would be different every morning. Okay, so they did find some, like an Enigma machine and a piece of paper. There were some pretty dangerous operations to steal Enigma machines or the piece of paper with the code. The code was on a piece of paper that had soluble ink in it, so if it ever fell off a U-boat into the water, the other codes would disappear. But there was an operation where I wouldn't say they stole an entire U-boat that Germany never found out about. They literally rowed over in this little boat, and hopped on, and the Germans had tried to scuttle it. They tried to blow it with explosives, and they actually managed to get down. And imagine rowing over to a boat that is rigged to explode. Tell you what, like, better. I wouldn't have rowed in that boat, but they did, and they So what they found was a few things. There was some flaws with the Enigma machine in that a T would always be something else, and a W would always be something else. So a letter would never be encoded as the same letter, and because of that, you could write out your guess beneath the gibberish, and you could be like, well, look, my guess can't be here on the line here because the two T's line up, and my guess can't be over here. So I could move it down. That would help. They also tend to have very regular weather reports where they would say this is the weather in German, and they also would say Heil Hitler at the end of the message to because that was the thing back then. So that also helped, and it was enough that Alan Turing was able to build a big machine with the first kind of big kind of computer to basically figure out all the remaining possibilities. So I want you to write a program here that what it does is, let's say, this is the best part, is the Russians back then in their tanks, the Russians were more like quantity over quality. They didn't, they used a cipher, literally like the Romans. So you can write a program here that would be able to crack some Russian codes. In fairness, Russians didn't have, in their tanks, like at the start of World War II, only the commander tank in a big group of tanks would have a radio. So the rest of them were like, had gaps in their armor, and they'd get out mid-battle and start flagging, and signal flagging to other tanks, while the Germans would be watching, behind their bulletproof glass on a radio going, are they serious? Are they serious? So later on they did upgrade to radios. You can see if I print out, let's say I get an intercept a message, I don't know, is it a +4 cipher or a +5? You want to write a Python program that just prints out so basically do it for a +1, write out the answer. Do it for +2, write out the answer. For +3, write out the answer. I've copy pasted a segment here. And you can see here, like on line 20, suddenly English words pop up and you're like, oh, they're using a +20. I see. And now you know their message system for the rest of the day. Okay, and you can do one for minus as well. So if you can make that program, you'll be able to find any cipher. I guess what I would do is if I was a really, really crazy one, well, I suppose it'd be strange to go above 26, but unless you had to loop around the whole alphabet again, you could, and then just do a search to look through your program for the word there, and it would. There is always the giveaway encodes. 3 letters beside isolated. Okay, so that is the task. That's pretty much it. The only just thing to say as well about this, right, is this, if you were to run that, it will end up with your letters in a column, so just that, it's not going to be quite as nice as this. So you'd have to add in basically this, bring that down and put something like it into your for loop if you want them all nice together. There's a few other ways you could do it. You could put a list at the top and an empty list and keep appending these into a list and then just turn your list into a string at the end. So yeah, you could do that too. But anyway, that's it. Have fun with it.